think we got it. I think we got it. Here we come. There it is. Hey there, friends. Good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. My name is Jeff Fritz, and this is C# with CSharpFritz. This is another one of our sessions in a series here where we're going to be talking about, we're going to dig in and talk about some beginner topics for folks that are getting started with C#. And in this series, this season, this session, this collection of sessions that we've had here, we're talking about Azure services, how we can make the most of cloud services using C#, taking care of getting in there and getting our C# skills from just building a little application that runs on our desktop to running out on the cloud and doing all kinds of cool things. We've talked about app service. We've talked about serverless capabilities with functions. And today we're going to talk about Azure Storage. We're going to get in and talk about reliable, simple to use storage services that you can use at a very low cost that are accessible from anywhere, any device that's connected to the internet. Let me take a look over here at chat. Let's bring on the chat. Of course, we start with an AMA here. This is a discussion. This is more of a talk show than a reference video. Let's talk to the chat, see how things are going, answer some questions, and then we'll get into the body of our content here. Let me head over. Let's bring on the chat room there. Right over there. We've got 40 minutes of AMA. My goodness, look at everybody who's here already. Hello to, is it Dirk Wynn? Hello. Egon Allison is here from South Africa. How you doing there? Papiska, how you doing? Yanesco, how's it going there on Twitch? Over on YouTube, Kent is here from the Philippines. Hello, hello. Why so super? Why not? Why not? How you doing there? Thindall is here on Twitch. Napalm, how's it going there? So, yes, I've got my super C# hat on today. Today's also the second day of the Microsoft MVP Summit. There's a bunch of folks, various influencers from around the internet that write blog posts and create videos. They're out at Redmond meeting with and getting connected to folks from Microsoft and learning about some of the cool things that are coming over the next month or two, particularly at that Microsoft Build Conference. Make sure you check out everything about the Microsoft Build Conference, build.microsoft.com. We've got a bunch of product announcements. We're going to show you cloud announcements, .net, and other dev tools announcements that you're going to see there. Great stuff coming up at the, what is it, middle of May. You'll see that land. I'm going to get some music playing here in the background, and we'll dig in and answer some more questions and chat with the chat room here. This is the Stream Beats Lo-Fi playlist. This is music that is DMCA free, royalty free. Listen to it wherever you'd like on the internet. You can have it in the background while you create your YouTube videos, Twitch streams, even listen to it for free if you really like the groove. Check it out. There's playlists available for Amazon Music, Apple Music, and Spotify, like I'm listening to here. Big thanks to Harris Heller and his team of creators for putting this music together that we're going to listen to today. It's great to just have it in the background while we're writing code and having a good time chatting. So, yes, Nitro Stream Racing over on my channel. I put together a wrap for that game that we play sometimes on channel. So while we're racing, you can have a cool car with a blue body and the Super C# logo on it if you play Nitro Racing. Does the YouTube link work for chatters? Yes. Yep. Folks on YouTube are getting messages relayed back and forth. There you go. You can see Martin chiming in there. Hello, Martin. So, since we don't have a number of questions here yet, let's talk a little bit about Azure Storage and what this means as we get into this. Azure Storage is a way for us to relatively inexpensively and with massive scalability put content, files, text, data in queues or in tables out on Azure and have it either replicate to various locations around the cloud, around the internet, or have it available for all kinds of applications to log in, connect, and interact with. You even have options available to you where you can serve files directly from Azure Storage as though it was another web server. So maybe you want to have a collection of images that are available to you, and I'll show you a sample of that later, where they're just available out on storage. The cost to deliver those to read and make those available to folks is very, very low. And it's easy to get started, load content in there, and start working with Azure File Storage, Azure Blob Storage out there. Air Homer, hello, good to see you. Trying to implement exception handling middleware for a .NET college project. I don't know if I should make custom exception classes or not. What would my advice be? You're creating middleware. So middleware tells me that you're building a web application. Middleware in a web application feels like it shouldn't have custom exception classes, because really you're going to be returning, if there is some sort of an exception, you're going to be returning an appropriate message. You're going to stop processing and immediately return an error code, right? You could pass along an exception to other elements in the HTTP pipeline. It's your choice how you do that. I would prefer not to throw exceptions. My preference would be to stop processing and return a message at that point. However, if you are using a custom exception handler further down the chain that you're managing on your own, then I would set up custom exceptions to pass along there, right? When you think about how ASP.NET, how the web server works and interacts with your processing, right? There's a series of middleware that your requests go through. So you can configure, right, an exception handler that puts up a standard error message screen. Oh, sorry, there was an error. We've logged it and processed it. That's what the standard screen looks like that comes with ASP.NET. You can also turn that off and you get a nicely formatted exception screen that comes out for developers to interact with. If you've built in, you're running your own exception handler and you can handle and log and retry your exceptions appropriately, yeah, build custom exception objects. If I was building just an API that was interacting and delivering content, I wouldn't build custom exceptions. I'd handle those requests, those exceptions directly, and emit appropriate messages to the folks that are requesting, so that it becomes very clear exactly where and how it happened. I prefer to handle my exceptions as close as possible to where they occurred and not let that exception object bubble through the entire application. But the preference is yours. So larger application, it makes more sense to have custom exceptions and a custom exception handler that's going to format and present an appropriate screen or retry. So I hope that makes sense. I hope I talked around in circles there a little bit. I hope that makes sense for you, Air Homer. All the best to you and your project. Let us know how it goes and where you land with that in the future. I'd be very interested to see how your project goes. My Microsoft Learning mug today. Next question coming in from Abdul. Regarding Azure Functions, how can authentication and authorization be applied to protect from improper access? So there's several objects at play here with Azure Functions. When you are talking about authentication and authorization, you're typically referring to an HTTP trigger. Now, with queue triggers, service bus triggers, these types of things, they're being triggered by another service that's on Azure. You've already authenticated and wired up and said, listen to this other thing over here. So there really isn't authentication and authorization because something already landed on that other service that is triggering the interaction in your Azure functions. So really, when we break this down, you're talking about HTTP triggers. There's an initial authentication capability where you pass a key. And there's two types of keys. There's keys at the service level and at the function level. And I think they call it an admin key as well. You also have anonymous capabilities. So those keys are issued from Azure and are managed over there. There are other capabilities that you'll find to set up OData, connection and authentication with your Azure functions, by routing through Active Directory. There's documentation for that as well. I haven't personally used it. They tell me it's easy to set up, but there's configuration options you can do to route through OData, and then you need to check roles and things on folks. But you can do that level of authorization with your HTTP triggers. There is documentation out there on how to do. Darn it! There we go. On how to do Azure functions and not OData. I'm sorry, I said OData. I meant OAuth. My bad. There are ways to do that. Yeah. And there's a blog post here on the tech community website about this. Yeah, that'll get you started. It's an open API security, open API operations that you define. That'll get you configured with that. I'm trying to find. There was a really good article about this, and because the access token and the authentication tokens are, because it's really configured at the service level. You don't necessarily have folks logging in and then being able to set authorization differently. I'll share this link to this article from the tech community blog, and you can dig in and look a little bit further on that. But it'll get you started, pointed in the right direction. How you can do this, and you can do similar interactions with static web apps as well. Cold Hands 18 asks, can I talk about output caching, which was introduced in .NET 7 versus Redis caching? Let me make sure I remember the output caching in .NET 7, because I primarily have been using Redis caching. I want to make sure that I have this right. Yeah, the output cache middleware. I want to make the output caching middleware grabs the response, grabs the actual content of the response, and puts it in memory. Yeah, and it's very similar to the old output caching that we had in ASP.NET Core, where you could vary by the route, vary by headers, vary by query string keys, and set durations that stuff would stay in memory. The output caching with Redis is a way for you to set up and put the response over somewhere else in a Redis database so that it's managed there and also then available for other web servers in your server farm. right? If you've got multiple servers, if you put it in a Redis cache, instead of having to regenerate that content every time, it'll fetch from the Redis cache, which is a very fast in-memory database that you can store and fetch data from. It's optimized for that high read-write interaction, very low latency because it's all running in memory. So you can set up, you used to be able to set up Redis caching as a cache provider. Way back in ASP.NET. And I'd be surprised if you couldn't use Redis as an output cache provider. And I don't see anything about that. Because it makes perfect sense to have a large Redis service available there. Yeah, here we go. Making .NET 7 output cache implementation with Redis. There we go. ASP.NET cache, output cache provider for Redis cache for Azure cache for Redis. That's weird. But yes, there is a Redis capability that you can do to put it over there, which will load very, very quickly and present. So Redis is a general purpose in-memory database. You can store all kinds of things in there. I'm storing, for the ClipTalk application, I store the currently live channels on Twitch in Redis because it's very fast. It's going to change frequently. I don't want to spend time writing that to disk. Just store it in memory, and as it changes, update it and serve that content. So you end up with a very nice database that's able to serve that content very quickly to folks. Your concern is about calling Azure functions from a mobile app, says Abdul. Okay. Folks have to log into your mobile app and then call your Azure functions. Or your mobile app has the keys and things to access your application embedded, and they're able to access it that way. The other service that I would look at is API management, where it's a little bit easier to issue and manage keys and interactions and control security from there. But that's another layer on top of Azure Functions or any other API that you might expose. Andy on YouTube asks, isn't using Azure too risky for most people? Because unless somebody understands perfectly, they could end up spending billions of dollars a second, and that would bankrupt the majority of companies. No. Several things prevent that type of problem from happening. You can set a budget for your Azure account. You can set a maximum spending limit, and as you approach that limit, you'll receive notifications, hey, you're at 50% your limit, 75%, and warn you as you're approaching your spending limit and give you an option to either extend your spending limit or shut down services when you hit that maximum budget per month on your Azure account. That said, Azure Storage is fairly cheap, and you're going to know as you get in and start scaling and hitting scenarios where you might start being concerned about cost. We'll bring up the pricing page. Let me bring it up over here in a browser, and I'll talk briefly about it, and then when we start the actual session, I'll be sure to go here so that you know and you can see this, and I'll share the link in chat if you want to go look at it now. There's the link to pricing, but if you scroll down, it's 15 cents American per gigabyte that you store in Azure Storage. That's for the first 50 terabytes. If you're storing terabytes of data and you don't expect it to cost you hundreds, thousands of dollars or euros or whatever your currency might be, you need to really rethink things here. When you start dealing with hundreds, thousands of gigabytes, you need to appreciate that that's not cheap. That somebody has to pay for that disk. So be aware you're going to be helping pay for that. There's different service levels also for Azure Storage. Between premium, live, hot access that is always there, always live for you to interact with. Cold storage, which is available and kind of a little bit archived and is available for you to keep on disk, cheaper, but it costs a little bit more to read from it. And then archive storage, where it's very cheap to store on disk, and it costs significantly more to go fetch it. So having that type of archive available out there for some folks who need, you know what, I have financial documentation that needs to be stored and archived for 10 years. Well, you don't want to be paying hundreds of dollars each month for 10 years. There's a significantly reduced rate. Looks like almost 80 to 90% reduced rate for keeping it out there for long term and to have that type of secure access to it. There is a cost per 10,000 writes and reads. Per 10,000 reads from the live storage is a half a cent. For 10,000 reads. For 10,000 writes, it's 6.5 cents. So Azure Storage is optimized for more reads than writes. If you have more writes, well, Azure Storage might not be the right place for you. And these are the trade-offs that we make when we're choosing various services. So, all things to keep in mind when you're choosing how and where you want to use various services. So I wouldn't say it's risky at all because you can set a budget and because the initial pricing is so low for getting started with these types of services. Once you start storing large amounts of data, yeah, you have to pay for disks. How you doing there, Hammer88 on YouTube? Welcome. Good to see you. To be fair, not even a space launch costs billions a second. That's right. Launching a rocket into space, what is it? Is it $500 million per rocket they launch? Or $50 million American? Like, that's... The average billionaire can afford that, right? If you're a company that is worth a couple $100 million, you can send a rocket to space. You're not going to run into that type of the concern of runaway costs in the cloud. You're going to see similar concerns and similar fear, uncertainty, and doubt around any online pay-as-you-go service on technology. So, let's see here. Thindoll says, after having to go down to a server room to replace hard drives and rebuild RAID arrays for 2 years in a row between Christmas and New Year's. Thindoll noped out, took the extra cost, and moved everything to the cloud. Right. Let's think about this. When you do store data in the cloud, you don't actually care who makes the disks that your data is stored on. You don't care. You don't worry about if those disks fail or not, because it's up to the provider to manage that. The compute services that are connected to those disks that read and write and allow you to interact with them, you don't care. You don't have to care. It's all been abstracted away from you. It's just an API endpoint that you get to connect to and work with your data. That's pretty cool. There's people out there that are working in these data centers that are replacing drives, replacing hardware, other hardware, power supplies, and whatnot, and Those people work all the time. So you're not only paying for access to that hardware, but also to those service people who are making sure that you can always access your data. And I guarantee it's a lot cheaper to pay those folks than it is to pay somebody like our friend Thindall here, who was over the end of year holidays at the data center working on and managing those interactions. So not fun, but somebody does that. Hammer asks, what's the best value for moderate picture or document retrieval? Best value for moderate picture or give me a little bit more context there. What do you consider moderate? How many gigabytes? What size? Are we talking about pictures that are high def, couple hundred K to store, or are we talking about like photo quality? A couple meg per each picture. Even then, are we talking about total of gigabytes that you're storing? Terabytes? Because if it's just something that you're storing for you and your family to access, use a service like OneDrive. But if it's something for your website, maybe you're building some sort of art display, graphic artist, community website. Azure Storage is pretty cheap for those because you're going to have artists publish once, and the reads on those you can definitely see benefit in paying for a low number of reads. Throw a caching service in front of that, like Azure Front Door, and now you have that content cached on the front end, so you reduce the number of reads that actually happen. So blob storage, yeah, fronted by Cloudflare or another CDN is gonna do you very, very well. There's options as far as redundancy in your storage. If you want it kept locally redundant, several copies in the local data center, geographically redundant, where there's copies stored in other data centers around the world, you're going to pay a little bit extra for that. But if something happens in the data center that your content is stored in is not available, well, that other data center that's over in another continent. I like to store my content in East US because that's where I'm located, but I might have a backup stored in Brazil. It doesn't matter to me that it's Brazil, it's outside of North America. I can store it there. I can put a copy in Western Europe. Fantastic. There's a copy over there if for some reason East US goes offline, and I can reroute folks to it. So you have options. And that's the best part of working with any of these cloud services. You have options. It's easy to dial up and dial down. Hey, I need a level of redundancy. I need a level of backup, and deploy appropriately. And you'll see an appropriate fee that goes with that based on the amount of storage that you want and capabilities. So, Andy asks, does OneDrive allow somebody to access the information programmatically, or does it always have to be manually done via the browser? You can use APIs to interact with OneDrive directly. You absolutely can do that. There's questions there that I would have around what APIs and how you're trying to access that. I think of OneDrive in this model as the very low impact way for you to interact and give non-technical folks a user interface to be able to manage content on a website or somewhere inside of an application, because everybody can open OneDrive and see a folder and put files, put images in there. And if you have an API that's just looking at, well, here's the files in the folder, go put these on screen, that's easy to do. You can also do something similar with folks being able to upload images into a GitHub folder in a repository. That gets automatically rebuilt, redeployed out to a service. Stuff like that is possible. mostly for in-house engineering documentation and images, but not high-volume reads. Honestly, I would use something. I would use something like a Teams channel then, because you can light up a files repository there where you can upload that documentation and be able to interact with that from other Teams services and features. It's if you're building something yourself, for managing that type of interaction, OneDrive might work nicely for you. You're going to be using the graph, the Microsoft graph to interact with that. Not bad. And all the authentication and authorization is already built in there, and you can configure that inside of OneDrive to interact with. It's a question of how much do you want to build versus buy and reuse. So as a document repository for engineering documents, I would highly suggest using something like Teams, because you'll also get search capabilities built in across those files. When you upload documents into that file collection inside of a Teams channel, you'll be able to get search and other capabilities, change tracking, all built in. So, thank you for the question there, Hammer. Regestia Martin asks, is Azure Storage support Amazon S3? It's Azure Storage. There are tools that will allow you to migrate content from S3 to Azure Storage, but the Azure APIs do not, and the C# features we're going to discuss today do not support S3. They support Azure Storage. Yep, that's right, Thindall. Using the Microsoft Graph. Andy asks, what is the purpose of blob storage if you have OneDrive? With OneDrive, all the blob stuff would obviously be useless. So, sure, let's talk about that. OneDrive is a very client-facing service that stores blob content out in the cloud somewhere. It's intended to be connected to services like Teams, like the OneDrive clients that come with Windows, so that you interact with it like it's another folder on your machine, and it kind of extends your disk space. Azure Blob Storage can be used by your applications where there isn't necessarily a person that's interacting with that to store and keep content out there that's specific to your applications. You can also use blob storage as an extension to your web server to store images, documents, other things that you want your web server to be able to store, but not necessarily have on the web server. Put it over there in blob storage, and folks can interact with that, read from it directly. Or you can even secure it, turn off public interaction to that Azure Blob Storage, so they have to go through your web application, your mobile application, to get that content. So if you were building your own photo sharing mobile app, you don't want your photos to be publicly available so anybody can just browse to it. You want folks to come through your app to get that content. So if I'm creating Fritzgram, the great new mobile photo app that you're going to use, and you take a photo, I'm not going to upload that to a web server. I'm going to upload that to blob storage and make that only privately accessible to when Fritzgram applications fetch data from it to present inside the applications. So, yeah, the virtual hard drives are stored in blob storage. Yes. You were thinking, well, the VHDs are actually stored on blob storage. So you tried blob storage once, but stopped because of hierarchy poor support. You can do hierarchies there. The V2 Azure Storage that's available has great capabilities there. OneDrive is one person's document storage. SharePoint is many people's document storage. And not just SharePoint, but Teams in there as well. And blob storage is a little bit more like an applications data store. Good, nice description there, Thindall. Is OneDrive built on top of Azure Blob? I don't have specific knowledge, but it's built on top of something similar, not directly Azure Blob storage. So, Fritz Graham confirmed. That's right. Maybe that's a Maui demo we need to build. Is the Fritz Graham photo app that stores content out on Azure Blob storage. What's this? Yeah, it's similar, but different. Can I make a ClipTalk integration for that? Interesting. That's interesting. We've got about 5 minutes left in our AMA session. Thank you so much, folks, for dropping in. It's great to talk to you today and talk about this. All the cool things that are going on. All right, Clipgram. I see how this is. No. How you doing there, friends on YouTube? Just taking a look, making sure that things are in place and looking good as we're getting ready. Since we're doing an AMA, what's the weather like? It's always sunny in Philadelphia. Things are quite nice here. Not too warm just yet. We had weather in the 80s Fahrenheit here over the last week, but right now we're in it about, it says 48 Fahrenheit here, going up to 65 Fahrenheit. So not too bad. Not too bad. Good spring weather here. It's going to be nice when I go out and cut the grass later this evening. You like the CSharp hat? Thank you. I had these hats made 5 years ago now, 2018. So that when I went to TwitchCon 2018 in San Jose, I had a hat on that made it easy to identify me. I had the CSharp hat on because at Twitch, I'm the CSharp guy on Twitch. So folks were able to find me, and then the following year I got the purple sequin blazer. Gosh, you've seen me wear this purple sequin blazer at various events, and there were people live streaming, walking around with GoPros and their phones and various devices around the TwitchCon event. It also at Microsoft Build that year, and there were literally people on Twitch going, "I just saw Fritz walk by," because they saw a flash of purple sequin go wandering by, and that was me. Any chance of me sharing some of the DST files? No. Hey, Alicia Griffin, good to see you. At the next conference, will I be in an animal onesie? Those are hot. Those are very warm. No. We will not be in the animal onesies. I have my Outlook open over here because with the MVP Summit going on, I'm going to be moderating a session right after we get done stream here today. But no, the animal onesies are very, very warm. I would not wear them in Las Vegas or Paris. No. And quite frankly, I will not be at TwitchCon Las Vegas. I have another conference that I'm scheduled to be at. I'm emceeing their live on-stream content. That's going to be broadcasting from Bulgaria. So, as much as I do enjoy going to Las Vegas, I'm going to be in Bulgaria. And Paris, I have other things happening, family things happening when the Paris event is happening, so I will not be at the Paris event. So it'll be the second year that I won't be at TwitchCon. How is hiring going at Microsoft? Or is there any hiring freeze? Asks Cold Hands. I believe there's still a hiring freeze. I haven't asked about. I haven't been a part of those conversations. If you go over to careers.microsoft.com, yeah, I don't see any jobs listed in my division. So I would say that there is still a bit of a hiring freeze going on as we're working through and adjusting to product shift, adjusting and normalizing staff levels as the pandemic ends here. Am I going to? Yeah, I'm not going to be at the Paris event. I'd love to go to the Paris event. A few years ago, when the Live Coders team was very active, I absolutely would have been at both events for it representing live coding, streaming tech online. But there just isn't as much interest. The team isn't as active, and it's a cost that I'm not going to bear myself to go to Paris. I would pay for myself to go to Las Vegas, but Paris is a little bit of a reach for me. Ahmed says, while you can create directories and put files in it, you can't ask the API to get you files inside only one of the directories. Yes, you can. You have to get everything in the container, then you have to deal with it. No, you can choose a folder and go there. So you can absolutely do that. Would have been nice to say hi if I was going to the Paris event. Yeah, sorry about that. I've absolutely been able to do that, Ahmed. So what you can't do is get a folder size with a single call. Correct. Yeah. You can get the size of a container and the actual content inside of it takes a little bit of work. But I would ask, why are you concerned about the size of the contents of a single folder? The grouping levels at a container level are such that if you were concerned about quotas or something like that, just make it another container. So, because you'll get those types of metadata and controls at the container level, not at the folder level. Can I point you to documentation? I need some context. Messages are going by here. Documentation on how to get content from a specific folder. We'll do it here in just a second. We're at the end of the AMA segment. Let's move forward. Let's talk about... Let's get in and start talking about Azure Storage and what you can do with Azure Storage. What's available for free? Let's start with the free discussion here. And I do have content on GitHub. It's not finished yet, and it's not complete. I'll take some of the questions here and add it into that content when we put that live, and we'll also have a complete set of source code after this stream. I've purposely left some of it blank, and because we're going to build it here live on stream. I think I also want to grab here, before we get too far into this, I think there's just an Azure Storage product page that we want to start at. Now that's the documentation, introduction to it, blah, blah, blah. Yeah, there we go. That's a lame page. That's a really lame page. All right, never mind. We're not gonna get in and talk about that. You know what? We'll start with this over here with Visual Studio Code. All right, right over here. And there goes Hey there. Here we are. So we're getting started with Azure Storage. On Azure, this is the easiest service for you to set up and get started with storing data. Okay. There are 4 different child services that come with Azure Storage that you can use to store and serve content to any device connected to the internet. Blobs, tables, queues, and file shares. We don't really use I don't really use file shares directly. Blobs are those files or blocks of data that you're going to put out there that you want to retrieve and you want to be able to serve. You can even serve it as a static website, and there's a configuration option to turn that on. I'll make sure that I add that to my notes here. So see, really, you're killing me here, Visual Studio. Thank you. Let's add some docs around static website. I want to make sure you see how to do that as well. But these 4 services out there allow you to interact with your data. Tables is a great NoSQL style database where you have schemaless storage, but you have a partition key and a row key for every record that allows you to search, traverse that content, and bring data back. There is a little bit of latency in your reads, but at scale, you can read through and interact with this content very, very quickly. You can layer on top of tables things like Azure Cognitive Search that will give you that type of search interaction that folks want, so that you can have a huge set of data and search for content very, very quickly. Queues are a service that I use a ton with the ClipTalk application that I've been building. So this is that first in, first out storage mechanism that you can use to store a small block of data up to 64 kilobytes that you can load and read and process. There are poison queues available as well, so if there's problems processing data, it can be pushed over to a poison queue, or some folks call it a dead letter queue, so that it can be reprocessed later offline. So you have options there. And the file storage is the file system storage. You see it used by app service, so you can actually push extra files into there, and you can mount extra drives. You have it sitting out there. You can mount a file share if there's content that you want available to multiple app services. You have this availability to put that file storage out there. So if I've got, let's say, a Minecraft server, and I've stored all my data into a folder that's off on the side next to my app service, if something goes wrong with that service, it crashes, that data center goes offline, no problem. I can start up another app service, mount that same file share in another data center in another region, and when I remount that file share, start up, and now my Minecraft server is running again with all the same content. So lots of options based on your needs, and evaluating how you choose these is very important. I want to make sure that you are aware of these options. Going back to chat, let me catch up here. Mohsin Malik on YouTube asks, I need to upload small files from managed Windows 11 devices. What authorization options are there? I would prefer not to use a common single key across devices. We'll talk about that in just a second. You can use, so there are several ways that you can configure this, and we'll bring up and talk about that. In general, there are 3 options. There's an account key connection string that is the same for every person that connects in. There is SAS, which is I forget what SAS stands for. Storage Authentication something. I forget what. Which is a time-limited key that can be issued that is shared and doesn't really have a person associated with it. And you can also set up and use RBAC, role-based authentication, where you can grant specific roles access to it and to your storage. Folks have to log into Azure, be authenticated, and granted appropriate access to be able to work with that. No, it's not statistical analysis. Wrong SAS there. There's a link in the article down here that I have linked here. A SAS token, right? There it is. Shared access signature. That's what SAS is. And it's effectively a token that's issued specific to a device. Doesn't really have a user associated with it, but you request certain permissions and you get access. I'll show you how this works in a little bit. And of course, you can use Azure AD and you can specify specific users, specific roles are allowed access. And there's instructions here in this article, which is linked from the documentation I'm giving you from today's stream about that. So, and you can front all the uploads with other functions and applications that can control and verify that type of access. Lots of options available to you. Just depends on where you want to place the access check. It can be on the blob storage service itself, or you can have it inside of another cloud-based service that will do that authorization and hand off content to blob storage. Good question. Thank you so much for asking that. Happy to chime in there. Storage queues versus service hub queues, never really got the difference. We'll talk about service bus, event grid, those services. Probably, I think I'm not going to be online next week. I'm going to be on site at St. Jude, but the week after we'll talk about service bus and the various other queues that are available. It's amazing. There's so many services that do very similar things at different price points and at different throughput. Not just on Azure, but on the various cloud services. Yeah, I was going to say it's not Service Hub. It's Service Bus, Event Grid, and there's another one. I forget what it is off the top of my head. So, all right. There's a couple ways that you can test and work with Azure Storage locally. There was some folks in chat, they mentioned, gosh, I don't want to get wrapped up and start putting things out on Azure. It's going to cost me a lot of money. No problem. There's an emulator that you can install, and I particularly note it right here because these things change over time. And you wouldn't believe how many folks go onto older YouTube videos and complain, oh, this thing isn't available anymore. Yeah, the video's from 2018 and stuff changes. But as of April 2023, as of the time of this recording, there's a service out there called AzureWrite that you can install and use locally as a emulator for Azure Storage. Now, this will not let you install and set up your own server to work with, but you can run applications, servers on your local machine that work with this emulator. So, several different ways to get it running. It's automatically deployed with Visual Studio. You can install an extension with Visual Studio Code to use it. It's available via NPM. If you have Node installed, you can install and get this content. There's also a Docker image that you can use to work with it. And there's also a GitHub repository you can clone it from and set this up. When you run this emulator, if we copy this command line, and I will set up a folder here. Let's just write this into let's make a folder here called AzureWrite. There it is. And I'll write this into a little folder here, and I'll write a debug log over there. You make me sad. I didn't install on this machine. I installed it on my other machine. Fine. Let's install it. I have a different machine that I was building and testing on. Yep, grab the Docker image. You're up and running. You can also, let me show you what it writes here locally. I'm not going to get into that right now. So just run it locally here, and you can see it started a blob service that's listening on this port 10,000. The queue service is listening on 10,001, and table service is listening on 10,002. So it's sitting out there listening, and we can interact with it. What's interesting about this is, let's open another terminal. Let me go into here. So if I look at the Azurite, and let's open folder here. Come on. Check out what it writes. Let's zoom in a little bit there, make it a little bit easier. It writes a handful of JSON files. So for tables, it writes a little JSON file here that contains table information about the queue, and there's a blob storage folder here, and information about the blob entries, and a folder for queue storage. It's just a series of files that it writes to disk that are very, very small, to start at least, right? 28K, that you get to interact with this little node service that's out here acting like Azure Storage. So we've got something that we can tinker with locally to see if this meets my needs. Some folks were asking, gosh, I don't know if Azure Storage is going to be able to handle or work with some of these capabilities. Well, run it locally. Now we can interact and explore what those things are doing. So yes, start up that Docker image, put it into Kubernetes, go to town. Absolutely. I'm almost done my coffee. This is a problem. So that's available for you to test with, tinker with. I think there's something to be said for standing up an Azure storage service on the cloud that if you have a distributed team, be able to point everybody to a test storage account, interact over there with some sample data, and use a live service to interact with and see how that works for you. So, how you doing there, Brave Cobra? Good to see you. So, I've got a little service here working, but then I really recommend you get your hands on Storage Explorer. Storage Explorer is a fantastic tool. If you've watched my other streams, you've seen me using this. It's a fantastic tool that gives you that same file browser capability to look around everything that's running inside, everything that's stored inside your storage accounts, and be able to tinker with those. So there's a link in the documentation that I'm sharing with you. I'm going to start my copy of Storage Explorer here. Let me I'll copy this link into chat for you. That wasn't the link. There it is, opening behind me. There you go. There's the link to Storage Explorer. So if I go to here, there we go. So you can log in to your Azure accounts, and you can see my Azure subscriptions down here. But you can also look directly at the emulator, and I'm going to, pin to quick access, and I should be able to. Why won't it let me search from here? Lets me do that on these. Why won't it? Whatever. So I now have access and I can browse around the content that's written inside of Azure Storage on my local emulator. So I have blob containers. Come here, you. Right? And I can create containers. These are like folders that we can create and work with here. So images. And now I've got a folder here, effectively, that I can upload, download, interact with content right here inside this tool. Queues and tables we'll get to in a little bit, but you can see my hat collection, right? You've seen my hat website that I've worked with here on stream, right? If you go to hats, csharpfritz.com, right? You've seen this website that has information about various hats in my hat collection. These are being served directly from the blob container over here containing my hat images. And there they are. And it looks like a file storage, right? I can see these are JPEG images stored out here. And I can download and get access to these images. I'm just double clicking. It says starting transfer down here, transferring it. It's using SAS. It's using, right, that token. And there's this hat image. So that's being presented on the website. So all this content, real easy to get to, serve, interact with. I see the file size out there. And yep, this hat, I just showed it. There you go. Yes, blob storage works with the rclone tool. Yep. So delete all the things you want to do here. There's also history. You can manage snapshots and versions of files out here as well. Really cool. But what we want to do is, as C# developers, we want to interact with this content. We want to be able to do stuff with this. So I'm going to delete this images container here. Yes. And we're going to work with the local emulator here. So I can get a connection string here. It's hidden. Doesn't really matter that it's hidden because it's only available here on this machine. So I'm going to copy that. I have full permissions to this. Why does it say? No. I'm going to copy that content, and let's write a little bit of code to interact with content inside our blob containers here locally. Hey there, Arshia. Hello. So I have over here inside my code, I wrote a little class here called blob demos, and there's a SAS string that we don't need, but here you can see account name dev store account 1, and it's going to, when you look at the whole connection string, it's going to the local address. That key doesn't matter if you see it because you can't connect to my machine, and even then there's nothing on this service. I don't really care, but you see that it's just connecting in and interacting with the local machine 127.0.0.1. So with that connection string effectively out there, I can connect to the blob service. And I do that with this blob service client. There's a package you need to install to get access to it. Can it be any easier to pick up the name for it? Azure.storage.blobs. Add that package to your project, and you can start working with a service client to go and get content from there. So all kinds of things you can do once you have that client available to you. So that's a blob service client. There's several clients in the mix here that you should be aware of, right? Now, when we have that client, I can generate a SAS URI, right? I can generate another connection string and request appropriate permissions and an appropriate duration for that. You see, I can request from a collection of permissions and specify when that URL expires. Okay, so I can have a base connection that knows just how to generate these things and spin out an appropriate URI so that folks are allowed to connect and hand off that permission to do specific things over a certain amount of time and access certain resources. Now, those level of interactions and control over that, let's go over to the Azure portal and take a look at how this is set up and how that interaction happens. So let's stand up a brand new storage account. Yep, create a new one. Thank you. That's fine, and we'll put this in. I'll put it in my CSharpFritz resource group, and we will call this C# with CSharpFritz. I can't type. Okay. Sure, I'll put it in East US. There's performance capabilities, general purpose, and premium that has low latency capabilities. I'm going to stand up with just standard. How do I want my content to be backed up? How do I want the redundancy handled? Locally redundant, which is the one I normally choose. Geographically redundant, it puts content into a secondary region. Zone redundant, which puts into different zones. And geozone redundant, optimal data storage that includes offerings of GRS and ZRS. So you end up with your data being spread out several places around the world. For most folks, use the local redundant storage. That's going to be plenty for you. So there it is. Going to create all that stuff. That's fine. Go. Retainment periods. You can control how long things stick around before they're deleted if you want. All kinds of stuff. So this is going to go create this initial service for us. And these usual storage doesn't take that long because it's a very low level service. Other services that you find on Azure are built on top of Azure Storage. So these dependencies you see. Yeah. Thindal with a fantastic comment there. So there is a storage browser over here that is an online version of that exact same storage explorer capability. It's all here in the browser. When you do click into this, it does recommend, hey, maybe you'd like to actually use, here, close that, right? It does recommend, hey, maybe you'd like to use Storage Explorer. It's just off screen down here at the bottom. Hey, go check out and use that. It's a little bit faster. Okay. But you can see an Explorer online if you are on your phone or somewhere else where you don't have Storage Explorer installed. And you can dig into each one of these. Thank you. Those SAS tokens, the access control, configured over here. So you can define who's allowed to access content, what they're allowed to do. All of those capabilities are over here, very similar to the interactions that folks normally have interacting with other Azure services. Access keys, so you can get a connection string that allows you to connect and interact with it. And there's a connection string that looks very similar to the one I generated locally. I'm not familiar with the Azure CDN. This is something new to me. What's this do? Yeah. So you can replicate your content a little bit better to get content a little bit closer to folks. Shared access signature was what I was talking about briefly, where You can define what permissions you want available and generate a key for an IP range if you'd like that allows folks to do those various things. So think of this almost like an anonymous granted access to your storage account. You control these keys and you can expire them, you can interact with them, but set them for a short amount of time so that they just disappear. You can always request another one. I've already shown you the API that allows you to interact with it. So, all right. So this is how you can do things online, and you can also encrypt content at rest here if you'd like. All this is configured out there on Azure. I can connect and interact with that. If I go back to Storage Explorer over here, I created that in my Microsoft employee account, and there's C# with CSharpFritz storage. So put that on quick access. Thank you so much. There it is, and I can work with that online service here, and I can see all the things that are in it. All right. Yeah, content at rest encryption is a huge selling point. Yes, yes, yes. So there are servers in the ocean, right? Project Natick, I think it's called. Yep, where there's a submarine with servers stored in underwater just off the coast. It was originally just off the coast of Ireland. And I don't know what the next steps are with that. But, okay, let me head back over to our code. So you can generate your own URIs, connection strings for folks to get into. You need to create a container in order to interact. You saw me right-click and generate a container. I can create a container with whatever name you'd like. Let's create one called images, and I'll grab a hat image or two, and we'll load stuff in there. So this is going to work locally, and I can say, if it doesn't exist, go create it, and I can specify the public access type. Let me comment out these other, so we can do some of this up front. So create the container if it doesn't exist. I don't like to use this all the time. I like to really do this in some sort of a startup configuration block of code. If I don't just go out into the service, right click, create container, right? Do that so that I'm not doing this. Unless you're creating containers programmatically with programmatically generated names, I avoid this. So there are ways to get list of containers that are available. So not just create, but you can delete the containers. You can get the list of containers that are available if you need to explore and see what's out there. Because how do you think this is building these things? There's an API that it uses to go and list the containers. So you can do that if you'd like. But let's get a container client for a folder that it doesn't exist, and then I can specify the access type on that container. And this is where I was saying a little bit earlier, you control how folks can access that. So there are several different enumerations that you can look at. I love how thorough the documentation here is. If you specify blob container, full public read access to the container and the blob data. So folks can do a list and see what are all the files that are inside of this. If you specify blob as the option here, it'll give you read access to the blobs, but you can't list the content that's inside the container. And none says that, well, you need to have an access key to get in here and be able to do anything with this. So let's let's make this, not blob container, let's make this blob. Yeah, there we go. So create it if it doesn't exist, and we're connecting to my local service here to do that. So I'm going to go back over here. I have a program. So sure. And I will say blob demos demo. And I'll go back to this. And let's .NET run that. And it says hello world, but if I go back over to my other thing here, it doesn't say anything happened. I'll go back to my Explorer over here, and if we look at the local, there's blob containers, and it didn't, you should have, I didn't await that. I see. Take that async off. Take that async off. I didn't wait for it to finish. Go ahead, do it again. And refresh. There we go. Now I have images over here. So now I've got a container that I can interact with. I can put content in here if I'd like. If I go back to here, let me find, let's find a C# logo that we can put in there. I can just drag in a super C# logo, transferring it to it. And I have a 256 by 256 logo out here now that it opens and, oh, come on. There we go. And it's there in paint.net. Okay, fine. You interacted with the Explorer, you put something in there. I can get that list of files and interact with that, right? So I can get that list here, right? And we can go through that list and take a look what's in there. Oh, Copilot, look at that. Writing out exactly what I want to do. I'll .NET run, and it found there's C# 256 PNG. So I've shown you how I can upload by just dragging and dropping a file into the container. I can see that that file is in there. I can also upload content asynchronously to this, right? And this is where you might have some sort of block of data file that you want saved out there that folks can download and interact with very easily, right? So it wants a name and a stream of content. So I'm not going to do upload blob async. I'm going to do, yeah, just a straight upload. Let's call this myfile.text. And I could create a stream of content. So let's create a memory stream that just works here in memory. And thank you. Yes. Right into that memory stream, just hello world, and flush the content, put it back to the 0 position on that stream, and now I can say upload that stream, and it will write that file, myfile.txt, out to my Azure Storage. Now, it could be any stream. I'm writing a text file here. And I'll refresh over there. There's myfile.txt, and it starts off as an application octet stream. It thinks it's a binary file that's been uploaded instead of a text file. I can not just specify a cancellation token, binary data. I thought there was a way. There's a way to specify the content type. And yeah, that's fine. If I download this content, yes, download, right? What are you doing? No, don't do it. Don't put that over there. Double click. Downloading it, transferring it. There it is, and there's my text file. Fantastic, right? I've now pushed content back and forth uploading my own content into blob storage. I'm able to download, I'm able to read it. And if I want to get that file, right? So I won't re-upload. So I'll get a new memory stream, download it to that memory stream, and I can, sure. Oh, I love this. Come on, Copilot. There you go. So, and I'll just write that out when we go fetch there, and there that second hello world came out of my file.txt. Cool. There's, of course, delete that you can interact with and delete files up there as well. Cold Hands 18 on Twitch asks, what does the hot inferred mean? What's that column there? That's the access tier. So when you create content out here, you can specify how long and what access that is made available. There's 3 temperatures to that. Hot, which is read write, it's always available. Cold, which is I want to write this once and I'm going to infrequently read from it, but keep it out there for longer term interactions. And archive. Yeah, thank you, Dukasoft, with the link there to the access tiers. And archive says, well, store this file for cheap on disk because it's going to stay out there for a long period of time. And I'm going to read it very, very infrequently. So data must remain in the tier for at least 180 days, right? For at least half a year. Not bad. Okay. If you need that type of archive, makes sense. So, yeah, hot is data that you're actively reading and writing. Cool is short-term data backup, disaster recovery. So think about backups of your servers, right? Backups of database. You would store out here. You write it once, and you might read from it sometime later. So, and you can set a blobs access tier on upload, right? You can actually use the user interface to do that. But there's, where is it? No, there's an API that lets you do that, right? So when we uploaded, that was a cancellation token. When we got the blob client here and we read it, we can also change. I believe there's an API in here to change. Yeah, set access tier. So by default, it's hot. I can change that here appropriately, and I should get. I'm not sure what the P options are, but there's cool, hot, premium, and there's archive way at the. Oh, darn it. Archive at the top. So, colder, the less money you pay. Yep, but takes longer to fetch. But like I was saying earlier, maybe you have financial documents that you want to store for a long period of time. Maybe you've got some sort of snapshot that you want to take that needs to be captured. Gosh, a startup I worked for, they wanted to put in escrow. Thank you. Remind me again in 15 minutes. They wanted to put in escrow all of their source code. Well, that zip file with the source code for the application that they were putting in escrow, perfect idea to put that into archive storage. It's out there. It takes a long time to access. It's written, and nobody's going to access that unless a disaster happens. And there's cool storage that we would use for a typical backup for 3 to 6 months that's just hanging out there. Yeah, AWS has a service called Glacier. Yeah. So, but we call it archive here in Azure Storage. So that's blobs and going through and starting with that. I wanted to talk about and get into queues. I didn't write the demo code for that one yet, but that's okay. We can write this live here, interacting and building a queue, reading and writing from that queue very easily. So let's make this, sure, fine. Let's get a queue client. And I think it's a, right, isn't it queue? I don't have the, what's it called? The NuGet package installed. So I do have links down here to the various articles to help get you started, the official articles, in case the content I'm showing here goes out of sync with how things work on Azure. Azure Core, Azure Storage Queues is the one we want. So let's .NET add package Azure Storage Queues. Adds all the packages we need. And we can now come back over here, and I believe, yep, there's my using statement for getting my queue client. The connection string is very, very simple to get things up and running. Folks typically store it over here in your in a web config, or you'll see it in local settings JSON. That's fine. That's fine. So there it is. New queue client, and we specify a queue name that we want to connect to. So let's specify a queue name and return new queue client, and sure. Use development storage is a keyword that you can use that will effectively route you to these services. And we'll pass in the queue name that we want. All right. So let's tinker with some queues. Do I know anything about vertical slicing? No, it's not the same as microservices. Vertical slicing is a way for you to take a section, a module of an application and put it into a project. It's not just microservice, but it's also the APIs and things that go along with that user interface. Put that all in one project, in one location, and merge those together later, either through HTTP client interactions or other API queries that you might do. Oh, look at this. Fantastic. Let's go get a queue client called myQueue. If that queue does not exist, create it. Everything with queues is messages that you send. So we can send a message. This puts a message into that queue. And content is first in, first out. We can delete the queue. We can get information about the access policy. We can peek at messages, receive messages, send messages, and even update messages that are already on the queue. Let's start off with just sending a message. We can then receive a message and get that value out and return and do something with it. When you're done receiving messages, though, you should delete it. I'm done with it. Get it out of there. Delete the message. But when you receive a message, no. What it does is it marks it as invisible. Nothing else can grab it. This is a way for you to kind of retry and interact with the same content in the queue. So there's a visibility timeout, like you see here, that you can say, well, I'm going to get a hold of this. I want exclusive access to it for this amount of time. So, okay. But you manually have to delete your messages. There's other techniques that you can work with the queue that I'm confusing myself on, that'll automatically do this, that'll complete the message and remove it from the queue. And you have to pass through the ID of the message you're removing, and then the receipt that says, this is my ID, this is proof that I have the message that I say I want to delete. So, if we do this, let's call it, say, so that we don't have another, let's just say, hello, CSharpFritz. All right. And I'll kick off that queue demo. So this will create that queue and start interacting with it. So .NET run. It's going to create a queue, put that message on the queue, and that's the hello world up here. Let's get rid of that so we don't confuse. And it brought back that message. If we go back over here to Storage Explorer, we look at our queues on the local emulator. There's my queue. And we see there's no messages in the table. Let's not receive the message or delete it. Let's just put the message on. So I'll rerun. Over here, I'll refresh, and you can see the message sitting out here in the table. And it's that clear block of text, and I can click in and see everything about this message. Here's it's encoded as plain UTF-8 content. It's got an ID. Here's when it was inserted, and it's going to expire in about a week. We can control and set that expiration for longer if we'd like, or shorter. It's up to you. Depends on how you need to process messages through your queues. But that message text is, it's nice, but if I need to push data through there, it might not be just clean text like that I want to work with. I recommend that you add some encoding to this. It's not in the API directly, is it? I recommend that you send base64 encoded content through there. Okay. That's going to get me it in UTF, but if let's ask not ChatGPT, listen to me. Let's ask GitHub Copilot to do it. Encode the message, hello CSharpFritz, in base64 for transmission on the and send on the queue. You're not going to suggest it for me? There it is. Convert to base64 string. There it is. Hello, CSharpFritz. What's next? You're not going to do it. All right, fine. I could say the client, send message, and it's a base64 string at this point, so I can just type the message, and that will go out encoded. Refresh. So there's the second one, and the message text appears here clearly. If I double click into it, decode as base64. I can see it. It's the user interface here is decoding it, but the way that it looks is base64 encoded. This makes sense because if I was pushing some information on here that was in, let's say, JSON format, that was something like, close, name, sure, that's fine, we can do that, right? So it looks like JSON format. We're going to send that information. Go ahead and push that out there. Now I've got something that's stored that is actually a block of JSON data. Look at that, Billy asking about JSON format. That looks like JSON data that I can work with, and when I pull it off the queue, I can deserialize it back into whatever object type that I might need. And now I've got a strongly typed object that I've passed across the queue that is smaller here in base 64, and we're able to handle. Remember, 64K is the limit you can send through here. Don't try and send through an image. Don't try and send through any kind of large binary data. It's got to be small. Little block of JSON for an object that you're passing around, no problem. You're going to have a great experience pushing that around. But if there is an image, or there is, in my case, I'm decoding and transcribing MP3s. Well, I don't want to pass an MP3 through my queue. I'll put a file down in a blob container, and I'll pass the file name through the queue. So when the record is picked off the queue, it knows here's the file name to go get out of the blob and work with. So you can start to put these services together to stack and create more value. So I can receive those messages and, of course, delete. We talked about that. So lots of cool capabilities that you can do with this. Now, I want to make sure that you do know there are no events on this API. Okay? You can't set up a queue client that is just sitting out there and listening for new content. You have to go back through and either peek and see if there are messages on the queue, or start receiving and say, go give me a message from the queue because I want to go work with it. All right. So, and of course you can clear the queue. Billy asks, are there any limits to the queue size? No. The size to the image to each entry on the queue is 64K, but you can have tons of entries there in the queue. I've got queues out there for ClipTalk with thousands of entries out there that need to be processed. So there'll be a process that wakes up and starts going through receiving messages off of it, and will continue processing until the queue is clear. So the queue storage is charged similar to how blob storage is charged. What the heck? Where did my... There we go. So Azure Storage blob pricing, there is, if we go back over here and we look at queues, I clicked on queues. Thank you. Per gigabyte per month, 4.5 cents per gigabyte. And there are costs for two different types of operations: create queues, update messages, clear message, delete messages. 0.04 of a cent per 10,000 operations. Same thing for get message, peak messages. It's 0.04 of a cent. So you literally have to push, right? If you push 100,000 messages through, it's 0.4 of a cent. If it's 1 million messages, it now costs 4 cents that month. 1 million messages through your queue. That's a lot of data. That's a lot of data. And I mean, 1 million messages that's going to get you somewhere. That you're going to be pretty successful before you start getting into, right, $4, right? Another 100 million messages to push through before you get to dollars worth of content that you're pushing. So, all right. So that's queues. Last one I want to talk about is tables. And tables are a schemaless interaction, and they label it Azure Cosmos DB for table for .NET. Like, could you put another product name on this? It is a deal. It really is. Service Bus has a similar cost. There's a lot more flexibility once you can do there. We'll talk about that one next time. Tables are pretty easy to work with. The limitation being that you have a partition key and a row key for every record. So let's add the package to work with tables here. And Azure Data Tables, go figure, right? That's easy to understand. I mean, the package names for these storage APIs, Azure Data Queues, Azure Data Tables, Azure Storage Queues, Azure Data Tables. Easy to kind of pick your way through and work with. Let's add a file out here for table demos. We'll create a public static class, table demos. Public static, I believe it's table client. I believe that's what it's called. I think that's what it is, right? Yep. Oh, look at that. So get a new table client, and we'll create a table called people to start. That's a great entry to start with. We can work with that. So public static void demo. There we go. So let's create a client. Thank you so much. And I'm also going to create a class down here called person. Actually, yeah. So there's a partition key and a row key that we need to create for our objects here. Oh, look at that. Right off the bat. So a partition key and a row key. How do we partition and place content into our table? A partition key is a group of records, and a row key uniquely identifies that record. So I'm actually going to reroute these. And we actually need to identify this as a table entity. Yeah, go ahead. That means it also has a timestamp and an E tag, so that it knows how long the data is fresh in the table. I'm just going to make those get sets. And actually, isn't there just a table? Yeah, we can do that. And I can hide these two because table entity actually has that value. Sure. Where is it? What don't you like? What are you upset about here? Yeah, oh, rats. All right, fine. Re-implement that. Blah, 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 blah. We're going to take row key and partition key and change those. But these ones, we're just going to make auto-implemented because storage service will set that for us. Now, storing these, folks, email really is a unique identifier for folks. So I'm going to change around row key and just point it at the email. And the partition key, I'm going to point at, now I could say people and give everybody the same entry there. Here's what I'm going to do. I'm going to make the partition key everything to the right of the @ sign in somebody's email address. So let's say email.split on the @ entry. There we go. And what don't you like here? You want to be able to set Fine. Return that. Set, I'm going to do nothing because I'm not going to let you set it. Return email. Oh. Not set, don't do anything. All right. And we got name and email sitting there. Fantastic. So I'm going to go get a table client. I can now say, let's create some people to insert in there. So, sure. Create the table if it doesn't exist. Yeah, there we go. Email equals Jeff at csharpfritz.com. Thank you. Let's create another person. Let's say, let's create Scott. And Scott is a new person. Yep. Email equals Scott at Microsoft.com. Thank you. Add that. Thank you so much. And let's also add Mrs. CSharpFritz. And there we go. All right. And I will set this up to run. How are we on time? Perfect. Perfect. Table demos. Demo. Thank you. And run that. There we go. Yes, yes. So now when I go back out here and we look at tables, we have a table called people. Click into that and I now have entries. And you can see names and email that are out there for these and when they were created. And you can see that partition key, it's the right part of the email address, csharpfritz.com. And we have Microsoft is where Scott is. So I can query this now and I can actually come through and say, well, give me everybody where the partition key is CSharpFritz, and it gets me just those records. I can also do this from inside my code, right? So let's create one more demo method here. Public static void demo queries. And let's do that exact same query here. Thank you so much. Oh. Copilot saving the day here. So, no. This, get rid of that. Yep, so we're going to get a table client, and that's really close to what I want, but it's not quite. I'm not creating, where is it? Query. I thought there was something for this. Hang on. Yeah, client.queries down there. Why doesn't it like that? Let's go back to the sample over here. Create, get. Yeah, there we go. There we go. Get entity async. No, I want to do a query. Table query. So this is my table client. Yeah. So now I should be able to say, can I do that? Oh, yes. And now it'll write out the people's names. So let's do last demo here. Come on. There it is. Thank you. And I will run it. And it found CSharpFritz and Mrs. CSharpFritz. Fantastic. All right, there you go. You can see that. So we've written queries to be able to interact with tables that are stored out here. And it it came back at a decent pace there. It's not bad. It's not, I mean, it's just looking at 2 entries that are out there. I could run this async. I could put a stopwatch on this, right? Thank you. Stopwatch start new. Give me my using statement. Sure. Thank you. And now it'll tell me how long that took. 10 milliseconds to run and get those 2 entries out there. There's lots more you can do with that. But it's easy to build and work with and have this schema-less storage out here in tables that are whatever shape you need to be. You can create extra fields out here and work with those and push them around as you need to. Okay? So we've talked about tables, we've talked about queues, we've talked about blob containers. Real easy for you to set up very small clients, push data out to fetch data from and interact with the content inside your storage service out here. And I worked with all that locally. If I point this out to my production space and work with it on Azure, you're going to get very similar performance, a little bit of latency because of network, but you're going to be able to work with that and interact with your data from anywhere that you have a machine connected to the internet. Let me head back over to the main screens here and let's wrap things up. Let's wrap things up for the day. Thank you so much, friends, for joining us today. I really enjoyed talking to you about storage today. Real easy service to use. So many things that you can do with it with these basic building blocks. Yeah, Ahmed, I'll get a sample for and include that in the sample code here for you when we get this published. I do have to run. I have to head off for helping out with the Microsoft event. Thank you so much for tuning in. If you're watching on YouTube, we've got more great content available for you. Check out the links just over here. There's other videos on the channel. If you click the channel name just below, great content available across all the .NET playlists and presenters out here. Make sure you check out the other live streams that we have available throughout the week here on the .NET channel. If you're watching on Twitch, we're on the Visual Studio channel. There's shows that are broadcast here live all week long, but it's time for a raid. Let's see who else is streaming on the big Twitch TV network that we can get you connected to, that's doing something fun, something interesting, that would be very cool to learn from. And you know what? Let's head over to our friend Tim Bodette, who is playtesting a game that he's been building called Retro Racing. So I'm going to get you sent over to Tim. Here comes the raid. There we go. Friends, fantastic to see you. I am not here next week. I'm going to be visiting with the charity organization, St. Jude Children's Research Hospital, but I'll be back the week after. I like Wednesday. I'm going to see if we can move to Wednesdays. We'll see if that works out. But we'll be back the week after, and we'll be talking about Service Bus. We'll be talking about Event Grid and all the cool things you can do with pushing data around and triggering other services using Azure. Have a fantastic rest of your day. Get ready to say hi to our friend Tim Bodette if you're on Twitch, and I will see you next time. Take care.